Hi everyone, this is Mr. Hall and this is a video about limiting reagent. Limiting reagent's hard. It's where the course on quantitative chemistry, like maths and chemistry, gets pretty difficult, whether you're doing at A-level or GCSE or otherwise. So hopefully this video will help explain some of the key ideas from this topic. There's two real objectives I've got for this video. The first one is to complete calculations involving moles, MR and mass. I'm assuming that you're okay with this. If you haven't, please just go back and revise that, because otherwise you'll find the rest of this far too difficult. And then the second bit is to determine the limiting reagent in a balanced chemical reaction. This can happen in one of two ways. You need to be able to do the mathematics involved in determining limiting reagent, and also need to articulate it in terms of a sentence. And this is the bit which I think students find the hardest, and hopefully I can help you out with how to do that. So the best way of thinking about limiting reagent is think about making a sandwich. Now let's say that if I'm going to make a sandwich like this on the right, I need 2 slices of bread, 4 slices of tomato and 1 slice of cheese. Pretty limited sandwich, but it'll do. Now if I'm going to make one sandwich out of all these ingredients I have in front of me here, I need 2 slices of bread, which is these 2, gone. I need 4 slices of tomato, which are those 4, gone. I need 1 slice of cheese, which is this slice, gone. And that gives me one sandwich. If I'm going to make another sandwich, I need another 2 slices of bread. I need another 4 slices of tomato. They've now run out. And I need another 1 slice of cheese, and that's that one gone. And then if I'm going to make a third sandwich, that's my second one made. If I'm going to make a third, I can use these 2 slices of bread. I can use this slice of cheese, but I don't have any tomato left. These have run out. Now, because it ran out first, it means you cannot make any more sandwiches because it's limited by the amount of tomatoes you've got. So we say that the tomato in this case is your limiting reagent. However, your cheese, you've got some left over here. So this is in excess. And your bread, you've got some left over. So this is also in excess. And that's basically the idea of excess and limiting reagent. Now, the exact same idea is applied in chemistry. If you think about the reaction that you did probably previously to make a soluble salt, such as copper sulfate, in this reaction, you would start with sulfuric acid and copper oxide. And then your teacher, if you did this, asked you to basically add loads of copper oxide to the sulfuric acid. You get a neutralization reaction where the copper oxide reacts with all the sulfuric acid molecules in that solution, and slowly but surely it makes 2 products. You make copper sulfate, which is salt, it's blue and it's dissolved in solution, and you've got lots of water. Now when you're doing this, you don't know that you've reacted all of the acid. So the best way of just double checking that you've done that is by adding copper oxide in excess. Now when you add copper oxide in excess, it will just land to the bottom. And because it's in excess, the acid is the limiting reagent because it ran out first. So the excess copper oxide, there's no more acid to react with, just settles at the bottom, it's in excess. Now that's all fine and well, but what you have to do is be able to determine this mathematically and put it in a sentence with those numbers, and that's where it gets really tough. So let's go through a couple of examples. So the first example here, it says 8 grams of hydrogen reacts with 64 grams of oxygen, determine the limiting reagent. This would typically be something between 4 marks, maybe more. So to complete this, we're going to follow this phrase which I like called bal-marak. And bal-marak basically means, it's basically broken into 4 different parts: the bal, the mo, the ra, and the k. The bal is balance the equation. Now in this particular equation, it's balanced, it's a 1:1:1 ratio, so we can leave that. The mo is moles from mass, and we'll complete some of this table in order to do this. You'll notice that I like using tables to kind of contain my ideas. Some people don't, but I find it really useful. So first off, let's put the formula in for the reactants 1 and 2. So formula 1 is hydrogen, and the next one is oxygen. And then for the mass, it's directly from the question. So I've got 8 grams of this, and I've got 64 grams of this. The MR for H2, it's 1 times 2, which equals 2. And then for oxygen, it's 16 times 2, which equals 32. Now the next part is to work out the moles available. And if you look at the equation triangle, moles is mass divided by MR. So the mass is 8, the MR is 2, so 8 divided by 2 gives you 4 moles. Over here, the mass is 64, the MR is 32, so that would give us 2 moles. Now the mole ratio is from what you've got in the question. Now you can see there's no numbers in front of the hydrogen and the oxygen, so it's a 1:1 ratio. So I'm going to write 1 here and 1 here. Now to work out the moles used, we're going to take it from the point of view of reactant 1, and we'll assume that all 4 of these moles have been used. So we're going to say 4. Now, if 4 moles have been used on this side, because you have a 1-to-1 ratio, you have to have 4 moles used on this side. Don't worry about the moles available yet. We'll come to that in our next step. So we've done moles from mass. Now we've done ratio of moles, and then we have to do moles remaining. So to do this bit, for the moles left over, it's going to be 4, take away 4, which gives me 0 moles, okay? And that's fine. However, for this one, I started off with 2 moles. I have used up 4 moles, so I've got -2. Now that seems to not make much sense, but what it's basically meaning is you don't have enough moles to satisfy this equation because you've only got 2, but you need 4. Now, because that happens, there isn't enough oxygen available, so this is the limiting reagent. However, your hydrogen, there's loads of, this is in excess. Okay? Now you have to put this in a sentence. So the best way of putting it in a sentence is like so. So this is a good sort of sentence, like writing frame that you might like to use. So by all means, use it for other questions. So I would say, I'll put this in the perspective of the hydrogen. So I'd say 4 moles of hydrogen will react with 4 moles of oxygen. I'm just using this information here to help me in terms of, in theory, what would be used. But there's only 2 moles available of the oxygen. Therefore, 2 more moles are needed for the hydrogen to fully react. Now, this extra 2 is this number here, because this is basically the deficit. This is the number missing, which is required to react with all of the moles of hydrogen. So that's a way of articulating this idea, and this is crucial if you're answering questions of this nature. Now, let's answer it the other way around. So instead of answering it in terms of hydrogen, we're now going to answer it in terms of oxygen, and this may make a lot more sense to you. So again, the masses are the same. We've got 8, we've got 64. The MRs, it's 2 and 32, and then the moles available, 8 over 2 equals 4, which would be 2, and then 64 over 32 equals 32. Now, the mole ratio is still 1-to-1. Now here, that should be 2. Now, if all these 2 moles react of oxygen, that means that 2 moles of hydrogen will also react because you have a 1-to-1 ratio. Now let's work out the moles left over. I started with 2 moles. I've used up 2 of those moles. I've got none left over. Here I start with 4 moles. I've used 2 of them. Therefore, I have 2 left over. Now you can see clearly that the hydrogen is in excess. So I'd write this as excess. Whereas my oxygen here is the limiting reagent. Now, to put this in a sentence, it would look a bit like this. So I'd say, and now I put it in the point of view of oxygen. So I would say 2 moles of oxygen will react with 2 moles of hydrogen, but there is 4 moles available of the hydrogen. So 2 more moles will be left over in excess. And that's your answer done. And it's really important, as I said before, to have that sentence. Now, you won't often get nice, tidy numbers like this. You'll probably have something a bit more complicated. So let's tackle something a bit more realistic. So let's have a look at this one. 2.45 grams of carbon reacts with 4.65 grams of oxygen to determine the limiting reagent. Again, we're going to follow the kind of the Balmaran model. So I'll put the formula in of the reactants, so carbon and oxygen. The masses, it's 2.45 and 4.65. And then your MR, so for carbon, it's just 12. For oxygen, it's 16 times 2, which is 32. Now, to work out the moles available, again, it's mass divided by MR. So it's 2.45 over 12, and I need to use my calculator here to get this done properly, otherwise I might make a mistake. So 2.45 divided by 12, and that gives me 0.204. And I'll just put ... When you're doing calculations with this, you want to kind of keep the whole number, but just to write it down in your working to 3 significant figures is fine. And then for this side, to work out the moles, it's 4.65 divided by 32, and that gives me 0.145. And again, ... Now, the mole ratio, again, it's 1-to-1. That makes our life a little bit easier. Now, the moles used or made in the reaction. Now, for this particular part, if I've got 0.204 moles here, and it reacted fully with the oxygen, 0.204 moles would also react over here. Now the moles left over here it would be 0 because you've got 0.204 take away 0.204 and that would equal 0. So I don't know why I put that point there. Now on this side it's slightly different because you started with 0.145 but you need 0.204. So if I take away the 2, and I'm using approximate numbers in this, so 0.145 take away 0.204, that gives me negative 0.0587, rounding to 3 significant figures. Now if you look at that, there's clearly not enough of the oxygen to react with all the carbon. So this is the limiting reagent. This is in excess. Now to put it as a sentence, really similar to what I've written before. So I would say, again, from the point of view of carbon, I would say 0.204 moles of carbon will react with 0.204 moles of oxygen, but there is only this much, okay, 0.145, so 0.145 moles available. So, and just to top off the sentence, 0.0587 more moles are needed for the carbon to fully react, and that's this number I've used here in order to do that. So it's a bit trickier. If I'm doing it from the other way, again, I just have to kind of show the same process, and again, this might make more sense to you. So carbon, oxygen, the masses are 2.45 and 4.65. The MRs are 12 and 32, and then the moles available, 2.45 over 12 equals, let's make sure I get this right, 0.204. And over here, 4.65 over 32 equals 0.145. Now the mole ratio again remains 1 and 1. Now the moles used, now let's do it from the point of view of oxygen. So let's say that all of my oxygen reacted, which is 0.145. If that's the case, then I would also assume that 0.145 of this also reacted. Now in terms of moles left over, I'm using all of this which I started with. So it'd be 0.145, take away 0.145, and that would give me 0. So it's basically these two numbers subtracting from each other. However, here I have a bit more. I've got 0.204 moles. So it'd be 0.204, that's what I started with, take away what I reacted with, which is 0.145, and that would give me 0.204, take away 0.145, 0.059. Okay, now you can see this is clearly the limiting reagent, which is consistent with what we found out before, and this is clearly in excess because I have that much left over. So again, putting it in a sentence, I would say 0.145 moles of oxygen, because I'm starting with this, will react with 0.145 moles of carbon, but there is 0.204 because I'm actually saying how much there is available here. Therefore, 0.059 more moles will be left over in excess, and that's it, done. So you can see you can do it from either way. That's my point. I think you'll never know which way is the most comfortable one. I think this is obviously the most obvious way of doing it because you can see exactly what's in excess, but as you work through it, it should become clear when you do your calculations. We'll do one more just before the video ends, and this is when the ratio can be different and can make it a bit harder. So here I've got 16 grams of hydrogen reacts with 64 grams of oxygen and determine limiting reagent. So again, I'll do it in terms of reactant 1, which in this case I'll make hydrogen, and over here I've got oxygen. Now the mass of hydrogen is 16, oxygen is 64, the MR 1 times 2 equals 2, 16 times 2 equals 32. Now in terms of mole available, over here it's 16 divided by 2, which gives me 8. Here it's 64 over 32, which gives me 2. Now the mole ratio is different here. It's a 2-to-1 ratio, so 2 to 1. Therefore, in terms of the moles used in this reaction, now let's say that all 8 moles of these got used up. Okay. Now if all 8 of those get used up, it's not 8 moles of oxygen that get used up because it's 2 to 1. It's going to be 8 divided by 2, which is 4 moles, okay, to be consistent with the mole ratio. This is really important. Therefore, in terms of moles left over, well, I started with 8, I've used 8, I've got 0 left over. However, here, I've started with 2, which is this number, but I've used 4, and that gives me -2. Now, again, I haven't got enough here to react with all the hydrogen. So this is my limiting reagent, and this is excess. And putting in a sentence, I would say 8 moles, and I'm using these numbers to help me as usual, kind of the theoretical. 8 moles of hydrogen will react with 4 moles of oxygen, but there's only 2 moles, which is this number, available. Therefore, how much extra do I need for it all to react? It's this 2. So 2 more moles are needed for hydrogen to fully react. Now we'll do it again once more just on the other side, just for completion. So if you remember from before, I've got hydrogen here, oxygen here. In terms of mass, that's 16, that's 64. The MR was 2 and 32, and then the moles available, 16 over 2 equals 8, 64 over 32, which equals 2. Now the mole ratio was a 2 to 1 because you've got the 2 here and no number there, so it's a 2 to 1 ratio. So the moles used, now let's do it from the point of view of oxygen. Now I've got 2 moles. Let's say I use all of those 2 moles. Now in terms of how many moles 2 moles of oxygen will react with, you've got a 1 to 2 ratio going this way. So 2 doubling up would be 4, okay? Now, if that happens, how much have I got left over? I started with 2 moles of oxygen. I've used 2 moles of oxygen, so I'd be left with 0. However, on the hydrogen side, I started with 8 moles. I've used 4 moles. I have 4 moles left over because 8 take away 4 equals 4. So this is clearly an excess because I've got 4 moles lying around. However, on this side, this is the limiting reagent because it's run out first. So putting it as a sentence, I would say, and we're using the theoretical numbers to help us here, I'd say 2 moles of oxygen will react with 4 moles of hydrogen, but there is 8 moles available. So 4 more moles of this hydrogen will be left over in excess. So as I've said before, and I've tried to reiterate, doing this sentence bit is crucial to pick up all of your marks. And that's it. So it's been quite a long video, but I hope that's been really useful, and best of luck with your limiting reagent calculations.